Welcome everyone. Today I'll be doing a college mathematics test 1 revision on the topic set theory, polynomials, and indices. First question. Given that R represents a set of real numbers, Q represents a set of rational numbers, Z represents a set of integers, and Q prime represents irrational numbers, which of the following is true? A good way to do this is to have our Venn diagram and just to remind ourselves what is a real number system. So we have irrational numbers that are by itself. So this is our irrational number. And we have set of numbers. Let's start with natural numbers. Then we have whole numbers. We also have integers. And then let me go ahead and draw another circle. So this last circle represents rational. So this is saying, the first one is saying that rational is within the irrational numbers, and that's not true. So we'll never have rational and irrational being a subset. So this cannot be the answer, neither can this be. Real number is every number that exists. So we can't have the real numbers being a subset of the integers. So we definitely can say C is true because we know that integers is a subset of the rational numbers. So you can see that integers is within rational. The next question, which of the following is an irrational number? Irrational numbers are numbers that cannot be expressed as a fraction. We know that square root of 4 is 2, so it can't be this. Square root of 9 is 3, so it cannot be this. Square root of 16 is 4, so that means it's B. Given that R represents a set of real numbers, which of the following is a member of the set? Pay closely to what we want. These are real numbers. And know that real numbers is every numbers that we can think of. And the range is saying that you have it greater than -5, but lesser than or equal to 5. 5.1 is over this side, so it's not inside the set. The number 5, because this is equal to, it's in the set. -5, there's no equal to, so that's why we can't use it. And -5.1 is over this side, so it's not in the set. So that's why the answer is B. The next one, the set of real numbers less than 8 and greater than or equal to -8 can be written in interval notation as. So the trick to this is to have our numbers. We have -8, and we also have +8. And it says less than 8. So here it has less than 8. No equal to is there, so that's why at 8 I'll have a round bracket. While for this part, you have it greater than or equal to. So therefore, for the next side, I will have a square bracket because of the word equal to. So looking at what I have, my answer will be A. So the interval -2, 2, where we have square bracket in both of these. So given that we have two square brackets, it means it's going to be equal to, so my answer is A. Now this says, given that px equal 2x cubed plus 11x squared plus 17x plus 6, and x plus 3 is a factor of px, then which of the following is true? A factor means that the remainder is 0. So when I solve for x, I have x plus 3 equals 0. Carry over the plus 3, so I have x equals -3. When I substitute p to be -3, all this is saying is that when I work it out, I should get 0. So my answer will be D. 9a squared minus 36 is the same as which of the following? So this is difference of two squares. So 9a squared. So 9 is the same thing as 3 squared. And 36 is the same thing as 6 squared. And difference of two squared, you're going to have 3a minus 6. And the next one, we're going to have 3a plus 6. So therefore, my answer is C. A factor of the following polynomial, you literally have to test. So let's go ahead and test values. So you literally have to substitute. So we have x minus 1. It means I will say x minus 1 equals 0. Carry this over. So we have x is equal to 1. And substitute into the polynomial. So I have 3, 1 cube minus 2, 1 square minus 17 times 1 minus 12. So 1 cube is 1, so 1 times 3 is 3. 1 square is 1 minus 2 minus 17 minus 12. Just by looking at this, we can't use 8. So now I have to move on for B. Let's just see if B is the answer. So once again, we are going to test, see if the value gives it 0. So it's x plus 1, so we carry the 1 over, so it becomes x minus 1. So replace negative 1 here, and let's see if we get 0. So negative 1 cubed is minus 1, so minus 1 times 3, that's negative 3. Negative 1 square is positive 1, but times this, I get minus 2. Negative times negative, that's positive, so we have plus 17 minus 12. So looking at this, minus 3 minus 2 is negative 5, plus 17, that's 12 minus 12, that's 0. So the answer is indeed B. The next question we have here, we have if x minus 5x squared equals 0, then the value of x is which of the following? So we have x minus 5x squared equals 0. X is common, so we factor the x, and we're left with 1 minus 5x equal 0. So what this is saying is that we make x equal this 0, so I'll have x is equal to 0. And the next part is the 1 minus 5x, so I have 1 minus 5x equal 0. So I need to solve where I have 1 minus 5x. So going ahead, 1 minus 5x equals 0. So I carry over the 5x. So I have 1 is equal to 5x. Then divide both sides by 5. So this cancels. So that means x is equal to 1 over 5. So that means I have two answers. I have x equal 1 over 5 and I have x equal 0. So looking at the options that's given, the answer is D. Now you can pause at any time and go ahead and write off jottings, or you want to work ahead and then check the answer. The remainder when this polynomial is divided by x minus 1, so we can either divide or substitute. So you have x minus 1 equals 0. So carry over the 1, so x is equal to 1. So I'm going to substitute. So I have 2, 1 cube plus 1 square plus 3 times 1 minus 7. 1 cube is 1, so 1 times 2 is 2. 1 square is 1, so I have plus 1. 3 times 1 is 3 minus 7. So 2 plus 1 is 3, plus 3 is 6, minus 7, that's going to be negative 1. So my remainder is C, negative 1. Number 12 is asking us, when simplified, 3 to the 2x times 3 to the 1 minus 2x gives us which of the following? So we have 3 to the 2x times 3 to the 1 minus 2x. We know the indices rule. We write the base once and we add the power. So the first power is 2x and the next power is 1 minus 2x. But 2x minus 2x, that's gone. So I'm left with 3 to the 1. And we know 3 to the 1 is just 3. So the answer is B. The solution of the equation 15x minus 9 equal 1. We have to make the bases to be the same. So I have 15 to the x minus 9. And 1 can be any base. So we'll have 15 to the 0. So we have x minus 9 equals 0. Then we carry over the 9. So x is equal to positive 9. So that means my answer is C. 81 over 16 raised to the negative a quarter. When we have a negative power, we basically flip the fraction and change the sign to positive. So this becomes 16 over 81 to the positive a quarter. So that means 16 is the same thing as 2 to the 4th. And 81 is the same thing as 3 to the 4th. And then we multiply each of them by a quarter. So multiply each power by a quarter. And what will happen? These cancel. These cancel. So you're just left with 2 over 3. So my answer is C. The square root of all of this. So the square root would cancel both squares. So that means I'm left with 9xy over 3y. The y cancel and then 3 into 9 goes 3 times. So I'll have 3x. So my answer is C. Now here's a structured part where we're going to answer. Let R be the universal set. By representing the sets A equal negative 50, negative 3, and B equal square bracket negative 5 in infinity, on the same number line, find A union B and state your answer in interval notation. So first, let's draw our number line. Negative 50 and negative 3. So because of the round brackets, we are going to have both of these being open and we connect. So that's A. And then we have negative 5 and it's a square bracket. So we have it shaded and it's going on to infinity. So that's B. So A union B, if you want A union B, it will be the entire region that we cover here. That's A union B. So we start at negative 15 and we're going on to positive infinity. Now at negative infinity, we have a round bracket because it's not shaded here and infinity is always open. For this question, it says a polynomial is defined by the following. Given that x plus 2 is a factor, find the value of k. So if x plus 2 is a factor, we can substitute to find k. So we have x plus 2 equals 0. Carry over the plus 2, so x equals negative 2. So we have f of negative 2 equal to negative 2 cubed plus 5 negative 2 square plus k times negative 2 minus 2. Now, when you substitute minus 2, what this is telling us is that our remainder is 0. So what we have here is a remainder of 0. Now, continuing, we have negative 2 cubed, that's negative 8, and minus 8 times 2, that's negative 16, plus negative 2 squared, that's 4, 4 5s, 20. This becomes minus 2k minus 2 equal 0. So minus 16 plus 20, that's 4, and 4 minus 2, that's going to give us 2. Just note that here, just to repeat, negative 2 cubed is negative 8, negative 8 times 2, negative 16. 2 squared is 4, 4 5s, 20. This is minus 2k and minus 2. If you don't like to work these out, you could carry them over first. So we have minus 2k, and then you carry over the 20, so it becomes minus 20. Then we carry over the minus 2, so it becomes plus 2. Carry over the minus 16, so it becomes plus 16. So this is minus 20 plus 2, that's minus 18, and minus 18 plus 16, that's negative 2. So we have minus 2k is equal to minus 2, and then divide both sides by negative 2. So this gives me k is equal to 1. So for part 1, we just found that k is 1. Now, since k is 1, we can go ahead and rewrite the polynomial. So we'll have 2x cubed plus 5x squared plus 1x or x minus 2. Now to factorize completely, we are going to just divide with x plus 2 because we already have the first factor, so no need to find a new factor. So where I have x plus 2, don't forget to change the sign. So we carry over the plus 2, so x equal negative 2. And let's do synthetic division. So we have 2, we have 5, we have 1, and we have negative 2. So the minus 2 goes on the outside. So we carry on the 2. Then we say 2 times negative 2, that's negative 4. Then you add 5 plus negative 4, that's 1. 1 times negative 2, that's negative 2. 1 plus negative 2, that's negative 1. Negative 1 times negative 2, that's 2. And my remainder is 0 because we add these. So our quadratic is 2x squared plus 1x or x minus 1. So this is 2x squared plus 1x minus 1. So let's factorize. Multiply 2 times negative 2, that's negative 2. So two numbers that multiply to give you negative 2, but when you add, you are going to get 1. So the numbers are 2 and negative 1. So 2 times negative 1, negative 2, and when you add, you get the 1. So my center I replace, so I have 2x squared plus 2x minus 1x, take away 1. So group, what can we factor out? We can factor out 2x. When I factor out 2x, I'm left with x plus 1. What can I factor out? I can factor out minus 1. So I'm left with x plus 1. So I have 2x, take away 1, and I also have x plus 1. So that means factorizing completely, it's 2x, take away 1, x plus 1, and x plus 2. That's it. That's how you factorize completely. The final question, we need to simplify the following. We have 6 to the 2p plus 1 times 9 to the 2p all over 3 to the 2p plus 1 times 2 to the 2p. So 6, let's split that. 6 is the same thing as 2 times 3. Then we have 2p plus 1. And then 9 is the same thing as 3 squared. Then I have my 2p. In the denominator, I have 3 to the 5p plus 1 times 2 to the 2p. The 2 to the 2p plus 1, the 2p plus 1 will be shared by both base in the first. Because remember, I changed 6 to 2 times 3. So both of them is sharing this power. So by right, we have 2 to the 2p plus 1 times 3 to the 2p plus 1 times, this will be 2 2's 4, so this is 3 to the 4p over 3 to the 5p plus 1 times 2 to the 2p. Now these have the same base, so we can simplify. So I have my 2 to the 2p plus 1 times, write the base once, and add the power. So we can add the 2p plus the 4p, that is 6p, and then you have your plus 1, and then over below, we are going to eventually simplify that. Now these bases are the same crossways, so you write the base once, then you have 2p plus 1 minus the second base power. So this is the next base with the power 2p. So the first power minus the second power. Then we have 3. First power is 6p plus 1 minus the second power, which is 5p. Let's write the plus 1 in a different color. Plus 1. So what's going to happen here, just to adjust my screen, we have 2. These are going to cancel, so 2 to the 1. While the next one you have 3 to the 6p plus 1 minus 5p, and then this will come minus 1. So it is 2 times 3 to the 6p minus 5p, that's p, and the 1 minus 1 would be 0. So this would be your answer. So just to repeat, we split the 6, then distribute the power here. 2 times 2 is 4. Then we went ahead, write the base once, and add 2p plus 4p, that's 6p. Then we have plus 1. These are the same base, so we write it once, and then we add 2p plus 1. Well, we subtract 2p plus 1 minus 2p. Write this base ones, then we have the first pole minus the second pole. So this become minus 5p and minus 1. So these cancel, but we have 6p minus 5p is 3p. That's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.